Python programming for Cambridge O-level computer science. So chapter 11 is programming concepts. In this chapter, you will learn about programming, declaration and use of variables, constants, basic data types, the things that you already know, integer, real, character, string, and boolean. How to use the sequence, selection, repetition that you already knew in the lower classes, sequence, selection, repetition, the three tools of constructing an algorithm, and plus you will how to total and how to count those things also programmatically. And finally, use of predefined procedure functions. So the introduction 11.1 is once we have written the algorithm to solve a particular problem, you all have done this, the three construct, the sequence, selection, repetition in pseudocode form earlier, but now we are going to do it programmatically. So when you do in like algorithm, in the algorithm stage, you can test by running it like rather dry running and using a trace table. But the ultimate test is to convert it to a computer program, because then only you will know whether it's really working or not. Your dry running or using a trace table, it's only manual. Only you are doing. You can make a mistake and you might think that it's right, or you might think it's wrong when it should be the other way around. But here, the ultimate test is to convert it to a computer program. When you do a computer program, it will, the compiler or the interpreter will definitely tell you whether it's right or wrong. So using the programming language, we write the source code. So now the pseudocode stage, we are going past that and learning the real code. It has to be converted to machine code before execution, because the Python code that we are going to write is not understood by the computer. Yes, it doesn't understand. Then it understands only the machine code, which is 0 and 1. Using zeros and ones, the machine code only the machine understands. So this is how it works. High level language, we use one of them and produce the source code. Source code, that is our instructions. And then using the interpreter or a compiler or the assembler for lower level, one of them. Usually we don't use low level. That's why I didn't include the assembler here. So we usually use high level, and in this course we'll be using Python. Or any other high level language, Java, C, anything, Pascal, interpreter or the compiler, you produce the machine code, That is how then only the computer will understand it and then execute it. So here are some samples. One is the Scratch. It's a very easy one. Then second one, the one that we are going to do Python. And a third, for comparison purposes, another one called JavaScript. And the JavaScript works in a browser. So let's look at all these things, right? Scratch is something like this. You can download it, and run when you want to run. Like I'll take a new. It's creating right now. It's a blank one, fresh new one for you. So to say hello, you remember the MIT App Inventor? App Inventor. something similar to that. So here we can use when say events, right? Event driven events. When clicked, when you click, we take it and drop it here. When click, what do you want to do? Say hello. We'll take this. Oh, yeah, just for the moment, this is enough. Say hello. That is because according to the book, the example given is that. Okay? Say hello world. So we can change it. We can type here, click here. Hello space world. We run it. Run that. You will see here. See, hello world. That's the output. Now, if I change it, hello. Hello, students. Then go here. It will change. The output change. So this is the output for that. Then print hello world in Python. You have already done it, right? But nevertheless, I'll just do it because it's there. So even here, so I'll take a new one. Not done for a long time, then this is the time to revise and get the idle. The shell will be there where you can perform immediate commands, right? You don't need a file to store a program. So here I will say print brackets and inverted commas because it's a string. Hello. Hello world and close. And then when I press enter, this is the one here, hello world, print hello world, and press enter. It says hello world, that's the output. Please note that this can be even single quote mark. Double quote mark, if I put single quote mark, also it will work. So just for your information, but my advice is stick to one, better stick to one. I usually use the double inverted commas, double quote marks. JavaScript. I don't think you have done in school. Maybe some learn extra things, so they may have done this, but other than that, usually in school this is not done up to now. So let's do this also. I have done it already for you. Take that file, JavaScript here. Here. No, this is the wrong place. Sorry, it should be not JavaScript, HTML. HTML and HTML because it has to be in
We have done. You showed us the HTML, sir. HTML you showed.
yeah, in the HTML.
Yeah,
Yeah,
sir, you should.
only JavaScript direction.
So we have to check the JavaScript. Oh, correct. That also you can. What do you use for that? The Notepad or any text editor, right?
Yes, sir.
I will just show it first, right? Show the code first, then run it. Here, this is the code. HTML. You remember HTML? We have done a little. The
Yes, sir.
starting and ending here. Head starting and closing here. And between the head and close head only, you get the JavaScript, not in the body. Usually what comes on the body appears on the screen here, and then this title, you already know that if this will appear at the top, the title tab, and then here, this is the actual thing, script language. This is a tag, remember HTML tags. Script language equals JavaScript. So we indicate to the browser that this is JavaScript that we are using. Then this is what document, that is that page, dot, the method is write hello world. So this is the output. And end of the script here, and end of it as usual. So let's run it and see. Here it is. It says hello world. Now let's look at the page source. Page source, here it is. Exactly what we typed. All right. That is how it appears. Hello world here. Right? So we saw the output, and let's go to the next section now. So you know that JavaScript works in a browser. We saw that in an HTML file. 11.3 declaration and use of variables and constants. Variable in a computer program is a name data store that contains a value that may change during the execution of the program. See, I will look at that again because it's very important. A variable in a computer program is a name data store. So it's a place where you store data that contains a value that may change during the execution of the program. Don't mix it up with storing data on the hard disk in a file. This is only in the RAM, in the main memory during the program execution where you store data. So that's data variable. A value that may change during the execution of the program. May or may not. Generally changes. That's why it's called a variable. It varies. Variable should be given meaningful names. Why? Because otherwise, if you're going to take the very first variable a equals 10, then b equals school name, St. Nicholas's International College, or C equals this, that, the grade. Then later on, when you go on for about 100 lines of coding, at that time you have A equals A plus 10. Then you're wondering, what is this A? What is this A? So you go back and look at it. Then when you come back here, you have forgotten what you were doing. So because of that, now if you have, instead of A, if you have age, then at once you know, even after the 1000th line of coding, if you see age, you don't have to go back and see what it is. You know that the age, and if it is a student age and there are parents or something like that, you know, the student age, if you give the name, that's more descriptive. Where there are two ages, two variables for two kinds of ages. So like that, it has to be like that. And that is not only for you. Supposing somebody else takes over your job. Maybe you are working at Microsoft, and if you leave, somebody else comes to take over that job, and then he will be at a loss if these are not named properly. So it's very important that you get used to giving meaningful names to variables. Constants should be clearly named. Constants which are not varying, no, which are not changing, but yet it's a good practice to store it in a data store. But they are also called variables, no? But then how do you indicate that it's a constant? Two methods of accepted ways. One is use of capital letters. Constants also, we as practice we give a name and then store it. Tell you the advantage of it. First, I'll tell you how to name them. Use of capital letters, say for pi equals 3.142. If you now we learn that we are using a number or something, say like this, first variable. We use the first letter capital and then the second word, first letter of the second word also capital, like that, beginning with capital letters, the words. Then there is a convention like. But this one, if all the letters are capital, that means it's a constant. So if we follow that practice, then it's useful to all the programmers, even to you yourself or the other programmers who will be looking at this program. So this is one way, pi equals 3.142, or else meaningful names that begin with const, like an abbreviation, const. So all the constants, if you have like this, then it's very easy. Then you can even use a simple I for this, any name for that matter. But then you indicate with this prefix that it's a constant. It is a good practice to declare all variables and constants at the beginning of a program. So sometimes you don't need this until the 100th line of coding, the 101st line only you need this variable, let's say some variable. But you don't wait till that time to declare. You can declare it there on the 99th line, that will be enough. The program will work. But it's a good practice to have everything at the beginning, like all the introduction, introducing all the variables and declaring and initializing at the beginning. All right. So now I'll tell you, I promised you to tell the advantage of storing these constants also in a data store. Imagine that you are using this 3.142 in 10 places for calculation, in 10 places. And don't consider this pi, will take something else like the VAT. You have heard of VAT or GST or service charge or discount. Let's say discount. Discount is 10%. So that's a constant, no? Like a restaurant, for all the items they are giving 10% discount, or I mean more than 1,000 rupees or something, you get 10% discount. That's all. But after some time, depending on the economic situation or the profits they have made, they change the discount to 15% or reduce it to 5%, whatever, there is some change. So you have to go and change everywhere you have used that rate. No? If you have used it at 10 places, all 10 places you have to go and change it. Whereas if you have used DIS or DISC or DT or discount, the full word, discount rate or discount rate, then you change only at the beginning here like this. Instead of saying this first var equals 20, you change it, the value here. The discount equals, early it was 10, now you change it to 15, that's all. All the other 10 places automatically, that is taking this variable name, the data store. So the constant, it remains a constant thereafter, but this change here, it's only in one place. So what is better, changing in one place or changing in 10 places? You can even make mistakes. One thing is more work, 10 times, takes time. And also you can make a mistake. You might change 10 and